Hello everyone, Suhail this side. Welcome back to my channel. So today we are going to deep dive into etcd. What is it? Why distributed systems rely on it like Kubernetes? How Kubernetes uses etcd? How to install and operate etcd? Command line, Java demos, and finally we will be doing a full Spring Boot demonstration showing config management, feature toggles, and leader election. So watch the video till the end, it would be fun. So without wasting time, let's jump in. So first of all, what is etcd? etcd is a open source, distributed, strongly consistent key value store designed to hold critical data in distributed systems. So it is built to store configuration data, metadata, and cluster state across multiple machines. So usually what you have in your microservice architecture, you have multiple machines, right? And also multiple services. So for example, order service, payment service, inventory service, you don't have single instance, right? So you have multiple instances of this service. So you store the configuration data, the cluster state, and also some of the metadata information reliably across multiple machines. So it is written in Go language. The name etcd is derived from two concepts. First, the Unix etc directory and distributed systems. So in the Unix or Linux operating systems, the etc is the directory or standard location for storing system-wide configurations for a single machine. The creators of etcd envisioned a similar function for their tool, but within a large scale, fault-tolerant distributed environment. So the addition of D represents this distributed nature, making etcd essentially a distributed etc directory. Now let's understand each and every word clearly. So first, key value store. So at its core, etcd stores data as a key value pairs. Think of it like a highly reliable dictionary. So it would be storing the key value pair in the format like the keys would always be stored as a /. So for example, my app /config, this would be a key and the value could be anything. For example, the JSON, text, binary, anything. Value could be, let's say, feature X is equal to true. So this is one key value pair. Similar to this, for example, you have multiple nodes in the cluster. You can store the node state. So for example, cluster node 1 is equal to healthy. It represents the node 1 in this cluster is healthy. So similar to this, when we have databases, usually what you have, right? You have the multiple services, service 1, service 2, service 3, service 4. So you have database, and to make the database fault tolerant, what you do, you provide another database that is standby replica, which would be acting as a primary as and when this primary database goes down, right? So at this moment, one database could be a primary and the another database could be standby, and this would become primary only and only when this primary goes down, right? So it's a kind of failover mechanism you provide over here. Now to understand which node is primary, to maintain this information also you can store the etcd. So for example, in etcd your D could be the database leader is equal to node 1. In short, in etcd you can store the node specific information, the cluster specific metadata, and configuration, which features are enabled, which features are disabled. So you can store all this kind of configuration and metadata in the etcd. Now let's understand the distributed nature of it. What makes etcd distributed? So usually what you have is you have the services and you have the database, right? So unlike a normal database running on a one machine, right, etcd runs on a cluster of multiple nodes. That means even if your one-off machine crashes, your cluster continues working. So typically what we do is we run etcd in odd numbers, 3 or 5 nodes, so that the cluster can maintain quorum. Now let's understand the third point, that is strongly consistent. What makes etcd as the strongly consistent system? So that means whenever you are writing the data, the system confirms it. Every future read will see the same data, right? If you see over here, that is the client. Whenever you are sending the write request, so every read request, even if the read goes to a different node, right, it should see the same data, right? So the write operation, how it is happening is the client would be always be sending the write to the leader, and the leader would be replicating the data to the followers, and then only it is committing the transaction. And after committing the transaction, once the data is replicated to all the followers, then only this leader would be sending the response back to the client that okay, I have written the data. So there is no eventual delay. There is no stale reads. Once committed, the data is guaranteed to be same across the cluster. So this property, we call it as linearizability. So if you see how etcd achieves strong consistency using a consensus algorithm, that is the raft. In a cluster, one node becomes the leader, all writes go to the leader, and then the leader replicates the data to the followers only after a majority of nodes agree. That means in this case, if this is a 3 nodes cluster, right? So when we say majority is 2 out of 3. So whenever the 2 nodes agree, then only the write is committed. So majority of agreement is called quorum. This quorum based model ensures safety and correctness. Now let me erase everything. What type of data you can store in etcd? Etcd is not meant to store large amount of application data like a traditional database. Instead, etcd is designed for small critical pieces of information like configuration, cluster data, service discovery, feature flags. Now everyone would wonder, okay, why we would create keys with forward slash. So as I mentioned in etcd, how the keys are being created, the keys are being created like a forward slash. For example, my app and the config, right? So that's how the keys has been created. So why we need forward slash? Why the key always has to be named like that? So if etcd is a key store, we can have like my app dot config, right? We can pass any key. Why it is specific to this order, right? So this is a very important question to understand. So when I say forward slash, it doesn't mean etcd creates actually directories or folders inside the file system. No. Now let me give you a real example why we need forward slash and why it has been designed in such a brilliant way. Now let's take an example of e-commerce, right? So you have the order service, but you don't have single instance of the order service. You have multiple instances, right? So order 1, order 2, there could be multiple IP addresses, right? So what you can do is to store the configuration, whatever the order instance 1 is being using, you need to store some configuration, right? Or the metadata. So you would be creating the keys as services, orders, and this is order 1 instance, and similar to this, the services, the orders, and this is service 2 instance. So these are the 2 instances of the order service. Now if I want to know what all instances are there in running state for order service, how can I get that? I can write it like this: the etcdctl, don't worry about this is a command line tool. I will be explaining this in some time, right? So get and services the orders, right? I can provide the prefix, so it's a kind of prefix operation which I want to do, right? So what it will do is it will give me all the order instances. So etcd supports prefix queries, and if you want to know what all services are available, right? So you can do, for example, in e-commerce site there is a one more service, the services and the auth service is also there, and there are few configurations, but you want to know what all services are there. So what you can do is you can, instead of this etcd service orders, you can just provide the services. That's it. You can get all the services which are present in the e-commerce application. So forward slash is just a convention to group related keys, enable prefix based queries. So with forward slash we can execute very powerful queries. So for example, if you have the config, right? So let's say the config and the prod, right? And you have the DB URL. So this is one key. Similar to this, you have the prod. Similar to this, you have the config and you have the staging and you have the DB URL, right? So you might be having different DB URLs with respect to the environment, right? So if you want to retrieve what all configuration is there in the production environment, you can simply do this: get config and prod and hyphen prefix. So you can get all the configuration which is present in the prod environment, and if you want to get the staging environment configuration, you can do that as well. But still, some people might argue that why it can't be done with the dot operator. So similar to this, you can also have like services dot orders and dot order one. So this, with this dot also you can segregate. But why forward slash is preferred? Because it visually represents hierarchy. When I say hierarchy, what it means is you have the services and you have the orders, and then you have the order one, order 2, and similar to this you have the auth. So that's what it represents, the hierarchy, and it is easy to understand. And also most of the tools already using the forward slash. So for example, Kubernetes, Zookeeper, Consul conventions, right? So everyone is using the forward slash. So it works naturally with the prefix matching, and this is a industry convention. So etcd is not a file system, even though we write like this, the config prod db url, right? It does not create any directory object, not any folders, not any implicit parent keys. It is just a string. That is it. So that's all from this video. Please do like, subscribe, and share my channel with your teammates and other friends. So in the next video, we will discuss why etcd and lot more other stuff. Thanks for watching. See you soon.